So going back to how we deal with the data. So now in this case, we had a very small data set that was kind of just to show the pipeline and also make sure that the simulation was fast enough that you would see more than a time step. So normally simulations are much bigger, but this to give you an example of how things scale. So this data set is actually from a microscopy, but again, it's the same type of rectilinear grids. And now I'm running off my laptop. The server in this case now is in Utah, so I'm streaming a fairly high distance. And now just to give you a sense of how still interactive this can be. And so I can add oops, sorry, this is the wrong thing to do. So let's say I want to add the slice in the middle. Here it is. So now this data set is really a high resolution. Still you have full interactivity. Obviously, even with a larger machine, we're talking about 6 terabytes, you will have no hope to actually load it in memory. And but that applies also even if it's smaller in terms of resolution. You have time-dependent data, you run the same problem. So in this case, this is the general environment. It's running, this is actually even an old version of our code, but running off a laptop. And so we actually have all those data sets off our website. So we'll show later how to access them, just if you want to get a sense of how they will work on your machine. We'll just get URLs around. And this is the type of capability and scaling that you want to be able to access. This is actually running on a smaller laptop. This video was taken on an old Windows Surface, and just to get a sense of how things can work. Did I do the wrong thing? Okay. So we apply this in other applications, a lot of subsurface data, seismic data, and variety is actually pretty broad. And for simulation, it's not just Cartesian grids, but also adaptive resolution data sets. This is an application that we've done for oil and gas, where they look at also very high resolution outcrop data, and we had some annotation capabilities. But then this is connected to their corresponding simulation in the underground for channel structure in the subsurface. And again, we were able to kind of visualize it and stream it remotely. The set of techniques that we're using underneath this code are based on streaming the data in a format that is cache oblivious. So this organization uses space filling curves instead of classical row major and column major. And that actually, it's one of the critical components that the data is not changed in any way other than the order in which it's being stored on disk. If allowed, we're actually introducing compression capability, but all works also for data with no compression at all. And in fact, we are targeting also some application in telemedicine where even legally compressing, modifying the data and compressing can be problematic. The other reason why it works, and those two have to be in tandem, that's why in things like ParaView and Visit, you don't get the full benefit of this, although we're making plugin to actually make it work. You need the streaming ability to process the data, so you get quick approximation that update the data on the fly very quickly. And you notice maybe you in the demo before, just to point the attention to how this works. If you see that when we move the data and you make a new query, initially you get a coarse representation, get fuzzy, and then quickly gets higher quality. That's the progressive computation that we have that makes the whole infrastructure work. and we apply that across the board for all the computation. And that's what's embedded also in the Python module and so on. So this is an example of deployment that we also will make another quick demo to show how to make it work. But I think it's an interesting pipeline that would apply in many use cases. So there is a microscope. This is actually a two-photon microscope. Each acquisition is in the order of 2K by 2K by 4K. So this is in the tens of gigabytes per image. So it's a 3D volume, and then needs to be stitched together. And so the microscope acquired the data. We visualize it in real time and fix potential error in the acquisition. Then for stitching in parallel, we connect it to a parallel machine and then put out the results so that the neuroscientist can get that easily done. An advantage is that the high-level Python interface allows to do all those things very quickly without also much expertise in parallel computing. So we'll switch now to demonstrating how to actually install from scratch the portal that you saw before. So in a way, now you saw a simulation running with PIDX. And in a way, that you can simply use also to dump and restart. And that would be just a traditional way of using the code with the advantage that it actually scale to very, very large machine. Often the I/O alone, it's very problematic, not for small simulation, but when they get large, it's really a challenge. So here we show the other side of the equation of how to get the code installed and make it work. So for the portal, what's interesting, and this is really an operation of a few minutes. Once you have Docker installed, that's only the main prerequisite, then on any machine you can just quickly download, install it, and run it. And then we'll show how you add data sets similar to what Georgie did before. So Steve.
Georgie has some data from Riken, so he can as well show this part.
You want? So I shouldn't do the demo. You want him to do it?
No, you can do it. Georgie has also some other data in case, but you can show
okay.
it. It's not at all.
Yeah, I'll first show the installation. So let's do it kind of together, step by step, and then maybe we can show. So maybe you can later show the screen maybe directly from there, and we're going to show other data sets. So let's see. So this is kind of the reference from the portal how to do it. And also we have a couple of data sets. If you want to try them just and as an example. So if people have Docker installed, I would actually recommend you might follow those steps with me because this is really something that you can do completely in a few minutes and you have it running on your laptop. Okay, so first of all, Docker.
Yes.
So let me see. This is
probably just running, so let's close it.
I have the viewer installed, so maybe I should minimize this.
Open another.
I'll open a PowerShell. This is on Windows. It works pretty much identical on other platforms. I mean, you just need a command line. So here I have Docker.
Pool.
So this is Docker running. Do you have the commands here? Or should I go on the website?
The website. I mean, there are really two commands. Docker pool. They are.
Well, yeah, but I just. Yeah.
Yes.
So this is the link you have there on that slide, and the description of all the information you need.
The data set also.
Okay, so here you see in that line the first command. So once you have Docker, you have to just do the pull. So here I have Docker pull, and so this is give you potentially an update. I don't know if people are trying in real time, but I currently have it installed. Otherwise, so it's going to check on the website, download, and do everything. So after this, basically you have all the software on your laptop. Yes. The Docker. Yes. Let me make another tab. So Docker, for people that are not familiar with this, has become a very fairly standard type of technology. Makes it very easy to install many type of codes. And so this is their main website. This is not our product. We're using someone else's infrastructure. And so here you can download their Docker depending on what is your platform. So for example, in my case would be Docker for Windows. This is something you get installed once. Obviously, periodically you may get updates. But here I can show this little icon, and and this would be the Docker installation interface. So yeah, if some people may have restriction on their laptop, so you might need an administrator to install this part, as any program you install on Windows. But once you install this, it kind of has its own layer. And by the way, it's convenient for many other things. So it's a type of technology that's convenient to have. I don't know if anybody has a question about Docker. Okay. So once you install it, so that's what I was trying to show at the beginning. So once you do the basic Docker command, you just write Docker, it gives you a help. But then you do this Docker pull. In this case, it's called VSUS Data Portal. So Docker download an image, and the beauty of Docker is that the image is portable, so it's going to run on Windows, Linux, Mac, unchanged. So if you have it to be installed now, it's going to take a little bit, like a couple of minutes just to take it down and install it, but there is nothing else to be done. It's all ready. So this basically does everything, install the information, and then here is the other command, and literally it's kind of very nice, that just 2 lines. And so this other command execute the container. So before we downloaded the container, if you don't have it or it needs to be updated, and then this Docker run and the parameters to run it.
So one important parameter here is that this port 80 -P 8080 column 80 is saying on which port of the machine the server is going to listen. So we'll see that later on we will use the same port 8080 to connect to the server.
Yeah, so here you see the port 8080 colon 80. If you're using that with another application, that number can be changed. We'll show later in the URL, that number will be there, so you just need to make sure that the 2 numbers match. So here, I just cut and paste that command.
You have it running already, so Docker PS.
So here, actually, I had it already running. So maybe it's good to show the situation. So I have actually, this container was already running, so it was going in conflict with that. So I'm going to kill this container. Now we'll restart it.
Docker stop.
What's that? Docker
Stop, and the ID of the container. You can use 097.
0977.
Yeah, it should be fine.
So just put the prefix. So now I do, again, Docker PS. There are no processes now. So I'll try it again. Oops.
It probably still didn't release the port. I don't know if you try again or just close and reopen Docker. Try to do the run again.
Okay, so probably still killing the other one. You wanted me to stop the container?
Yeah, stop Docker and reopen it.
So you do restart?
Try with restart.
Okay, so this might take a minute. So this is, so you see now Docker restarting. Anyway, this is kind of the worst possible scenario that you might need to restart Docker. So, and actually, if any of you is running this the first time, this is probably not happening because I have something left from the test I did yesterday. So it's still restarting, I guess.
Yes.
That's the only thing that I wonder if all the stuff I have open, it's a problem.
It always takes a little to start. Let's see.
I should give a sign when it's completed.
It should be still full. Okay, like this.
Try it again.
Yeah.
Okay. So that means it's active, right?
Yeah.
Okay. So.
Okay, that's working.
So after restarting the whole Docker system, now this is launched. So if any of you tried, you should have seen all this. This is just debugging information. It can be used in some case to track potential problems. So by now means now I have a server up. So those two comments potentially troubleshoot some basic things. And so now to run it, should I go to Chrome, I guess?
Yes, on the browser.
And then localhost 8080.
Yes.
Should I do :80 or just?
This would be fine.
Okay, so you see the URL. I just typed localhost :8080, and again that number refers to what we launched before. And so you probably now start recognizing this is the same that Georgie had before. So in this case, so when you get the portal up, so first of all you have a data set already there. So just to see that things work. This is a data set from NASA. So as you can see already, you have the ability to zoom in and zoom out and so on. So let's go back to the portal. And so so first of all, this is running. So and now you just add the data set.
Yeah.
So let me check that I have the data sets, or should I download them from that page?
As you want.
So, for example, I have this heart data set. This is a typical data set that is a stack of images. So just to give you a sense, this is a medical data set. You see typical. You have a sequence of images. and you can only look at them slice by slice. So the idea, let's put it on the server, so you have the two advantages that it can be visualized in 3D and also can be accessed remotely. So what's the managed data?
Yes.
So admin. So the password.
The default is password, as in the instructions. There are on the wiki there are details on how to change configurations, password, how to mount your external drives to load and save the data. There are, more advanced configurations you can make.
Anyway, so this is local. So now we'll try those two examples. So this is a stack of images. So we'll take this approach. So we'll go to the browser, and so here we literally do drag and drop of that folder into the server side. So this is we select that folder. As you can see, has automatically determined it has 256 files, and each one is an image that is 512 by 512. And so you just click on convert, and now in the background is running the conversion process. Okay, and then all you need to do is say add to server, and so here you have the list of data sets. So as you can see, so we have the blue marble, the one that we're showing before as a default. It comes with a Docker container, and in fact that one is, as you see, it's a URL, the redirect to our server in Utah. And now we have a local file. So this is similar to what Georges was doing before with the simulation. Basically, you just need to know the location of the folder with that file. So if you have the file system mounted in the location where you have the server, everything can work just fine. So now we update the server itself with the new file mounted. I guess we should try and reload it. Should we upload also the other data sets since we're here?
Yeah, try. Yes. On managed data.
Or should we go in order? I don't know.
Is the same.
Okay. Just want to make sure I don't delay things. So
go to manage data.
Yeah. Okay. So manage data. So as we do now, we convert something that is a single file. So again, browse. We get the file. So now here, this file asteroid, it's just a raw data set, raw major. It's a single block of, how much is that? 500 by 500 by 500. It's a float 32 data set. It's just the time it takes to uploading. It's actually.
Yeah, it's around 500 mega, something like that, 433.
Yeah. So it's. Okay, and so now we select the file.
Yes.
In this case, though, because it's a block, we have to write ourselves. This is 500. 500.
Simplify the name to asteroid. Simplify the name.
Yeah. Make the main a little bit simpler.
Okay.
And again, start the conversion.
Add to server the other one. Yeah. Save.
Ok.
Vedo
che è ancora rosso.
Sì. provide and also explore data. Look, check the logs. You can check the logs from. Check the log.
Okay, timing manage data. So, yeah, we have the log
Go
of
down.
the conversion. So you can check what's going on.
Yeah, no, it seems like it did it. It did the conversion. Yeah.
Okay. So the conversion
was successful. So let's go again and do explore data. See if there's a app on. Even here, go down. You can go and explore data directly. They should be there by now. Try to check the list. No. This is localhost. Yes.
Okay, we'll do the best.
Oh, yeah. So that should be up. Maybe need another refresh.
So now you see before those were red. So now they have become green. So now they should be available on the server. Unfortunately, I have a lot of stuff running on my laptop, so maybe it's delaying a little bit.
Refresh the page. I mean, by now they should be up. Okay, now there is
I see asteroid.
Yeah, try to change.
And
try to make a volume of it.
Okay, so this is the asteroid. It's literally an asteroid that's splashed in the ocean. I don't know if, okay, this is computing an isosurface. And kind of this is visible. Yeah, I think it was just cached. It was not reloading the stuff. And so the other one is the heart. Again, an isosurface, obviously. And of course, we can do volume rendering. What's interesting is that I can load those data sets also from a client. We'll talk about more about the client. So this is kind of the web directly, the web portal. But if I have my VSUS viewer, I can do file. What is that? Open URL. So here I type the name of the data set. In this case was the asteroid.
Yes.
Right. And then the server, instead of the one all the way there, it's local host. Oops. I have a tendency to
80. Okay.
So then, okay, and so you see the same data set in the actual VSUS client. We'll show later how this enables a bunch of other rendering capabilities. But so here you can see the. So let's
close the scripting just to have more space. I don't know. Close the scripting.
Yeah, so much. Okay, and so here is the typical aspect, and so. So anyway, this is kind of to give a sense how easily and how quickly you can install the server. You can connect to a data set, either through the local or you can even upload it, and that can be a volume of data in just as a block of raw bytes.